So, dear colleagues, I'm glad to present to your attention the results of the investigation named Asymptotic Assessment of the Functional Safety of Information Interaction in the SDH architecture at the network and transport OSI layers. I'm Vyacheslav Puftin. So, is the functional safety important today? After all, the focus of attention is mostly directed at information security. On the one hand, functional safety is directly related to the reliability of the hardware component, and there are a few unsolved problems in this area. Electronics works blamelessly for years, and if it is not enough, there is always the possibility to redundancy. But there is also a software component, which is precisely what the management of the security functions relies on. A typical example can be described. Can be the description of several cases when an error in the software of space apparatus management system costs millions of dollars, and those are far from the known cases. We can also remember various system projects which include mechanical, electrical, and electrical components. Unfortunately, failures happen all the time in such integral projects. Articles usually analyze cyber threats and ensure information security methods for the Internet of Things. One of the potential risks in the interception of control at the physical device level. An attacker can then force the control system to perform dangerous functions. In this case, information and functional safety are two sides of the same phenomenon. The property of information security should ensure the availability, integrity, confidentiality of data in the management system. The property of functional safety has to ensure the correct performance of the functions of the control system, and in the event of failures, transfer of control object to so-called safe mode. According to the authors, in modern conditions, no standard would be devoted to the issue of functional safety of the heterogeneous network communications, using the example of synchronous digital hierarchy SDH architectures, which are used both in the above-mentioned man-made objects and which connect them into a single controlled cyber-physical system. It was the point of gathering for this study. So, the object of the research is the process of assessing the functional safety of information interaction in the heterogeneous architecture at the network and transport OSI layers. The subject of the research is the theory of dependability, the theory of graphs, and the theory of experiment planning. The research goal is the analytical formalization of the asymptotic approach to assess the functional safety of the information interaction in the SDH architecture at the network and transport layers. So let's introduce the main result of the work. TCP/IP network hardware and software use IP addresses to identify clients and services. However, the people are more comfortable to work with symbolic domain names. The global correspondence between the domain names and IP addresses is ensured by centralized DNS. This system is based on a client-server protocol in which both DNS servers and DNS clients are defined. The function of DNS server is to support distributed database domain name IP address mapping for the corresponding domain. In addition to the name mapping table, each DNS server also share links to the DNS servers of each subdomains, forming a single system. There are two main DNS names resolution schemes, not recursive and recursive one. So it is the second scheme that is the most widely used, and we focused our mathematical apparatus on describe not only network SDH network architecture, but also in the information interaction in accordance with asynchronous DNS protocol. So we assume that each edge presents an independent connection between the corresponding nodal element of the network. The stochastic characteristic of the connection, which is the probability of its specified functions. Here and after specified mode, that is why we are talking about functional safety. Characterized by the characterized by the values PD and the inverse characteristics, which describes the probability that the connected functions is a mode rather than specified, so a non-functional mode is described by the no PD values. So we denote PG the probability of existence of a road between the start point and the finish point in the network architecture by the formula which we can see. We denote also the number of computation operations required to calculate the functional safety of the two between the respondent modes. This mathematical apparatus is rather computatively needs a big amount of computation. So we try to find the asymptotic procedure for calculating those parameters. We conclude the study of the radial ring architecture by accessing the set of the probabilities which the respected power. In the basis of our asymptotic approach, we put the Floyd-Steinberg algorithm. To detecting the elements of the set PG, we analytically formalize the recursive operation, which is can be seen at the upper of this slide. In this case, the number of computation operations required to calculate PG values is represented by the expression which we can see here. If we introduce the segregation in modal connection according to the state of compliance with the functional safety requirements, then the process of calculating capacity characteristics PG and no PG can be formalized asymptotically. So here is the basis of this formalization, and here is the result of those operations. So let's interpret these expressions. In the radial ring SDH architecture, the acyclic route from the starting node to the node located at the ring on the ring includes the following components: from the central node to the node located at the ring, and from the part along the ring node to the finish one. If the central node is the final node, then the second part of the road degrades. The minimal intersection between the starting node and the finishing node located in the ring can be represented by the sequences of intermodal connection between the arc of the ring containing the node, the final node, at the and the central node. Let's talk about experiments and results. We can illustrate the functioning of the proposed mathematical apparatus with an example. Suppose that we, as a result of the censored observation of the radial annual SDH architecture in the composition of the central node A0 and six nodes from A1 to A6, which are represented on the rings. Here we can see some parameters which describe this network architecture function. Assessments of the probabilities PAM unsupervised of the unspecified mode for interacted connections from A0 to A6 calculated according to expression no PG, which we saw at the previous slide, and summarized it in the form of the respective matrix. According to the structure of the network architecture, the two matrices PAM and no PM, PMK, are calculated, and we can see the graphical representation of those matrices at the slide 10 and slide 11. So here we can see the presentation of the matrices no PAM and no PMK. Now let's talk about these matrices. What is those matrices is, and why does this two slides looks so similar? So recall that the purpose of the asymptotical normal formalization of the analytical formalization of the asymptotic approach to evaluating the functional safety of information interaction in the SGA architecture at the network and transport oscillators. In the context, the author's concept should preserve the adequacy of the reference approach prevailing over the latter and in computational efficiency. As a reference, the statistically representative approach for calculating the metric PG and no PG for the network architecture described in the beginning of the section, the Monte Carlo method, which implementations was used. So PMK represents the results which are calculated by the etalon Monte Carlo approach, and AM represents the after approach, which asymptotic even a simple visual comparison of these figures can give us can allow us to make to see the fact that these figures looks very similar. And also the main advantage of our asymptotic approach. In fact, we use less in free order of magnitude calculations to get the results which are presented on the figure 1 in comparison with the results which we can see at the figure 2, which is represent the Monte Carlo approach. So in conclusion, In the study, the authors focused on the radio link SDH architecture, which is characterized by high versatility, immunity to interference, and at the same time, the authors take into account the specifics of the organization of the TCP/IP connection, which is the recursive sham of DNS involvement. So the article analytically formalizes the procedure of evaluating the functional safety of the information interaction in the SDH architecture at the network and transport also layers, taking into account the probabilities of specified and unspecified implementation modes of information connection. A comparison for the author's approach, which is a reference analog based on the Monte Carlo method, proved both the adequacy of the first and its superiority over the second in the computational efficiency of calculating the selected functional safety indicators metric by more than 3. So that's all. I hope that I took not more than 50 minutes. Thank you, dear colleagues. If you have questions, I'm ready.
Thank you, Vyacheslav, for your presentation. Dear colleagues, any questions? Vyacheslav, do you hear me?
Yes, I'm here.
I have a small question. Maybe can you admit some maybe weaknesses of your approach which are to be fixed in your future research?
It is the central question in any research. Thank you for this question. First of all, I'm focused on TCP protocol, but this is not the one protocol at all. It consists of many different algorithms which are automatically activated depending on the parameters of the data which are transferred through the network. That's why when I'm talking about network also layer, I'm indicate this field of research, but not represent this part in a necessary case. So I think that this is the most and oblivious task for the future research. And also we can we can take into account other oscillators, and so that if we it will be interesting for the scientific society, this research can be the starting point for at least I think 4 good articles. Thank you.
Okay, thank you for your answer. Colleagues, any more questions? No, thank you. So let's.
I will stop the presentation.